Hello, everybody. So today we're going to finish the last lesson of Chapter 9. We're on page 415 of the 5th grade Go Math textbook. And our topic today is graph and analyze relationships. And so the essential question you should be able to answer at the end of the lesson is, how can you write and graph ordered pairs on a coordinate grid using two numerical patterns? So basically we're combining a couple of the lessons that we learned in this chapter. Graphing ordered pairs and identifying the relationship between two numerical patterns. So it's nothing really new. We're just applying those two skills. So let's look at the unlock the problem. Sasha is making hot cocoa for a party. For each mug of cocoa, he uses 3 tablespoons of cocoa mix and 6 fluid ounces of hot water. If Sasha uses an entire 18 tablespoon container of cocoa mix, how many fluid ounces of water will he use? All right, so how many tablespoons of cocoa mix does Sasha add for each mug? 3 tablespoons. And then how many fluid ounces of water does Sasha add for each mug of cocoa? It says 6 fluid ounces per mug. So 6 ounces of hot water. So we can use the two given rules. Basically add 3 tablespoons for every mug of cocoa and add 6 fluid ounces for every mug of cocoa. So 3, then we would have 6, right? If we had 2, I'm going to go ahead and put the mugs up here. 2, 3, 4, and then so on, okay? So if we have 2 mugs of cocoa, that means I'm going to have 2 times 6 or 12 fluid ounces. For cocoa mix, if I have 3 mugs, it would be 9 tablespoons, and it would be 18 fluid ounces of water. In 4 mugs, I would use 12 tablespoons of cocoa mix, and I would use 4 times 6 or 24 fluid ounces. So basically, we start to notice a pattern here. So 1 times 3, 2 times 3, 3 times 3, 4 times 3. So if we take the number of mugs and multiply by 3, that tells us how much cocoa mix we're going to use. And then if we multiply the number of cocoa mix, what's the relationship between that? 3 to 6 is times 2. 6 to 12 is times 2. 9 to 18 is times 2. 12 to 24 is times 2. So multiply the number of cocoa mix tablespoons by 2. And so 18 plus 18, that's 36. All right, so now write the numbered pairs as ordered pairs. So we have 3, 6, 6, 12, 9, 18, 12, 24, so on, right? All right, now we're going to graph and label those ordered pairs. Then we're going to write a rule to describe how the number pairs are related. All right, so 3, 6 over right 3, up 6. Over 6, up 12. Over 9, up 18. Over 12, up 24. And then the last one we have in our table is over 18 and up 36. And then we can combine these segments and it forms a straight line, right? What rule can you write that relates the amount of cocoa mix to water? So for every 3 tablespoons of cocoa mix, we're going to multiply by 2. So multiply cocoa mix by 2. So they're going to use 36 fluid ounces of water if he uses the entire package. Now, write the final number pair as an ordered pair. Well, that was 18 and 36. We already graphed it. Okay, we can go ahead and write in our ordered pairs here. So we have 12 and 24. We have 9 and 18. We have 6 and 12. And we have 3 and 6. Okay. What do the connected points form? A line. And explain why a line is formed. Well, there's always a 2 times greater amount along the y-axis. For every x, it's 2 times greater, right? And so we can say the y-coordinate the second number, the y-coordinate, is always 2 times as great as the x-coordinate. So it means the points will be equal distance away. So the points are going to increase by the same amount. All right, try this one. Find the unknown term in the table. Each $2 bag of copper wire contains 6 meters of wire. Write the number pairs as ordered pairs and graph the data. All right, so we have 2, 6. We have 4, 12. We have 6, 18. And we have 8 and something. Well, if I go from 2 to 6, that's multiplying by 3. 4 times 3 is 12. 6 times 3 is 18. So 8 times 3 is 24. So now we can graph these to figure out the rule. So let's see. 2 over 2 up 6. Over 4 up 12. Over 6 up 18. Over 8 up 24. And again, we get a straight line. Okay, so it was 2, 6, 4, 12, 6, 18, and 8, and 24. So if we multiply the number of dollars by 3, that'll tell us the number of meters of copper wire. Basically, I get 3 meters of copper wire for every dollar. So the rule, multiply dollars by 3. All right, graph and label the related number pairs. For every 2 square feet of lawn, Charlie needs 8 ounces of fertilizer. All right, so we have 2, 8, 4, 16, 6, 24, 8, 32. So we're going to multiply the number of square feet by what to find the ounces of fertilizer. So if you tell me that we have 2 square feet, it takes 8 ounces. So that's 2 times 4. If I have 4 square feet, 4 times 4 is 16. 6 times 4 is 24. So it's multiplying by 4, right? So if I multiply the number of square feet by 4, we'll find the ounces of fertilizer needed. So 10 times 4 is 40. Okay, so we can graph that fairly easily. 2, 8, 4, 16, 6, 24, 8, 32, 10, 40. And we get a straight line. So that's increasing at the same amount. And number 2. On Mary's map, every 2 inches represents 10 miles. So if I have 2 inches, I get 10 miles. If I have 4 inches, I have 20 miles. 6 inches, 30 miles. So basically, if you tell me the number of inches on the map, what can I multiply by to get the number of miles? 2 times what is 10? 5. 4 times what is 20? 5. 6 times what is 30? 5. So we're multiplying by 5, right? You can also write that like that, right? And this one we could have written times 4. So multiply the number of inches by 5. So we have ordered pairs of 2, 10, 4 and 20, 6 and 30, 8 and 40, and 10 and 50. So go over 2, up 10. Go over 4 and up 20. Over 6 and up to 30. Over 8 and up to 40. And 10 and up to 50. Join the points and we form a straight line. So the rule for this one, again, is multiply the number of inches on the map by 5 to find the distance in miles. 417, number 3. On Sandy's scale drawing of the school campus, 2 inches equals 4 yards. The distance between the swings and the track is 10 inches on the drawing. And the distance between the track and the basketball court is 4 inches on the drawing. How much farther is the track from the swings than from the basketball court in actual distance? All right, so they do want us to graph this, so let's draw a graph. Okay, and we'll have inches along the x-axis, and we'll have the distance along the y-axis. So we can say distance along there. We know that that's going to be 0. And it looks like if we multiply the inches by 2, that'll tell us the distance. So if I have 10 inches, that's going to be 20 yards. So we have a distance, we'll use count by 2s up to 22. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. All right, and we'll count these as just ones. All right. Okay, and so this will be inches, map, in inches. Okay, and we have 1 to 10. All right, so our pairs are 2, 4, 4, 8, 6, 12, 8, 16, and 10, and 20. All right, so 2, we go up to 4. 4, so 3, 4, 4, 6, 8. I go 4 and up to 8. 6, 6, and up to 12. 8 to 16. Find 8, go right 8, up to 16. And 10 up to 20. Showing the points. A little off as far as a straight line, just because the spacing is going to be a little off without grid lines. Okay. So what is the rule? Well, multiply inches on map by 2 to get distance in yards. Or we can say to get actual distance in yards. So how much farther is it from the swings than from the basketball court? How much farther is the track from the swings than from the basketball court? So track to swings, the distance between swings and track is 10 inches on the drawing. So we said 20 yards. So track to swings is 20 yards. The distance between the track and the basketball court is 4 inches on the drawing. So in that case, it would be 8. So track to court equals 8 yards. So how much farther is the track from the swings than from the basketball court? 20 take away 8. 12. 12 yards. Okay. And number 4. Eric recorded the total number of push-ups he did each minute for 4 minutes. All right. So write the ordered pairs, number pairs as ordered pairs. So 1 minute, 15 push-ups. 2 minutes, 30 push-ups. 3 minutes, 45 push-ups. 4 minutes, 60 push-ups. Let's just graph that. So go over 1, up 15. Now I don't see 15 on my graph, but 15 would be halfway between 10 and 20. So I go to 1 and put the dot or the point in between 10 and 20. 2 and 30. 3 and 45. 45 is not on here, but it will be between 40 and 50. And 4 and 60. points. And what is the rule? Well, multiply time by 15 minutes, by 15 to get the number of push-ups. Okay. I want to go ahead and write in the order pairs on this one before I move on. So 2, 4. We went 4, 8, 6, 12, 8, 16, and 10, 20. Okay. All right, to 418, number 5. All right, Elsa solved the following problem. Lou and George are making chili for the annual firefighters ball. Lou uses 2 teaspoons of hot sauce for every 2 cups of chili. And George uses 3 teaspoons for every cup of chili in his recipe. So Lou is basically a 1-to-1. For every cup of chili, he's going to add 1 teaspoon of hot sauce. Whereas George is doing 3-to-1. For every 1 cup of chili, he's adding 3 teaspoons of hot sauce. Who has the hotter chili, George or Lou? Well, it says write the related number pairs as ordered pairs. So this is Lou's table, this is George's. So 2, 2, 4, 4, 6, 6, 8, 8. So in other words, 1-to-1, like we mentioned. And this one's 1-to-3. So times 3 times 1. So the number of teaspoons of hot sauce is 3 times as many as the cups. So these are their order pairs. Okay, Lou's chili, George's chili. And then they graph their amounts. Well, Elsa said that George's chili was hotter than Lou's because the graph showed that the amount of hot sauce in George's chili was always 3 times as great as the amount of sauce in Lou's chili. Does Elsa's answer make sense, or is it nonsense? All right, well, what happened when they both had 2 cups of chili? Well, Lou's has 2 cups, or 2 teaspoons of hot sauce. Meanwhile, George's has 6 teaspoons. Well, that's 3 times as much, right? 2 times 3 is 6. Okay, then when they had 4 cups, Lou uses 4 teaspoons of hot sauce, and George used 12. Again, that's 3 times as much, right? So yeah, her answer makes sense. So for any x coordinate, the y coordinate is 3 times as much. So for any x coordinate, if I even said 1, well, we see that Lou uses 1 teaspoon, George uses 3. 1 times 3. It's 3 times bigger than Lou's. For 3, we see that Lou's would be 3 teaspoons, and George's is 9. 3 times 3 is 9. So no matter what the y coordinate is on the line to George, it is going to be 3 times as big as Lou's. So her answer does make sense. All right, so that's it for chapter 9. In our next chapter, we're going to be working with converting measurements. So until then, I will see you soon.